Hi, and today we will discuss about a special type of processor called IO processor. Remember, we all know about processor. The processor is a combination of CPU, ALU, and registers. So it is a combination of processor is a combination of CU, ALU, and registers. But here we are discussing about a processor which is called dedicated processor. So the dedicated processor, why I am saying dedicated processor, it is called input and output processor. So it is called, it is not general purpose register, it is called dedicated processor. Why it is referring as a dedicated means it has a fixed job, like it has to execute instructions related to IO. So the goal of the IO processor is it has to execute IO instructions. First, let us try to understand what is the necessity of having a separate dedicated processor only for IO operations. As we know, IO operations are IO instructions. Execution of these IO instructions involves IO devices, and the speed of the IO devices are very much low when you compare with the speed of the processor. So if you use normal processor or general purpose processor, if you use general purpose processor, so what happens, it takes hell lot of time to execute those IO instructions, because IO devices are, the speed of the IO devices is very low. Speed is low for IO devices. Why? Because they are electromechanical devices. So as they are electromechanical devices, it takes a lot of time to execute IO instructions. Why? Because if these are my IO devices, each device will have a device controller, and this together is called IO interface, which communicates with processor. So all these IO devices are very much slow when you compare the speed wise. The speed of the IO devices is very much slow when you compare with the speed of the processor. So the processor has to be in the wait state, or it is get, when the device is ready, it can execute some instructions, but when it device is ready, it sends ready signal, then processor has to take that as an interrupt and service that. So it also some time consuming process if more number of interrupts are getting generated. So for that reason we have, if in case of multiple interrupts, we have a concept called software technique polling and hardware technique daisy chain. However, even in daisy chain or polling technique, considerable amount of time has to be spent by the processor. The processor has to spend considerable amount of time in executing IO instructions. So if it is possible, we deploy a processor which is dedicated to execute only IO instructions. And examples are, such example is IO processor. And another important concept we will discuss here, system bus. First, let us try to understand the input and output processor. So, as input and output processor is a processor with direct memory access capability. So that is most important thing. The first point about IO processor is that it is a processor with DMA, or direct memory access capability. So in this, computer system is divided into memory unit and a number of processors. So it's like this is my processor, and this is my IO processor. Both are competing for memory. This we have seen in when we discussed about DMA. So this IO processor should have the capability of DMA. DMA stands for direct memory access. So remember, when we discussed about IO data transfer techniques, we said that there are different kinds of data transfer techniques, and the most important one is DMA. If we have a single block of data transfer, then we can go for synchronous or asynchronous data transfer. But if we have a large amount of data to be transferred, then so if I have large amount of data to be transferred from IO device to memory via processor. So using this processor, the IO device cannot directly send the data to memory. So what happens here, it has to go via processor to memory. But the processor is busy executing other instructions. So when I have large amount of data, then better we keep, in place of processor, we assign this job to DMA. DMA stands for direct memory access. So here what happens, DMA takes this is my IO device, and it has some large amount of data. It has large amount of data to be transferred. Then if this is my memory, so it sends this large amount of data without involvement of processor. Without involvement of the processor, what happens here? The DMA initiates large amount of data transfer from IO device to memory. But the only thing that DMA and processor both share system bus. They both share system bus. In fact, DMA and processor both are competing for the system bus, and also they have only one memory, both DMA. So if it comes from processor point of view, the processor need the processor and DMA both are competing for memory, and both are also competing for system bus. So how to manage this? It is the most important thing. Now I hope you understand really what is the importance of this here. DMA is also called, is not actually, DMA is a smaller one, but if I increase the scope of the DMA, it is called IO processor. So first we should understand the difference between DMA and IO processor. So what happens if this is DMA, which has the limited job of, it has only one job. When processor initiates, so the DMA is initiated by processor. This is most important thing to understand. So the processor executes IO instructions. It tells DMA to transfer large data, but IO instructions are executed by processor itself. But if I have a dedicated IO processor, the processor will not say anything to this. Processor here executes IO instructions, not just transferring the large data. Yes, IO processor can also do the job of DMA. So it should have, IO processor should have the capability of transferring the large amount of data. But the thing is, IO processor is a dedicated processor which executes IO instructions. I hope you are getting what I'm trying to say. So input and output processor with direct memory access capability. So the IO processor has the capability of direct memory access. In this computer system is divided into a memory unit and number of processors. Computer system is divided into, we have now two processors, one general purpose processor and the other one is IO processor. So each IO processor controls and manage input and output tasks. See, there can be n number of processor. See, if this is my This is my processor. There can be more than one IO processor 1, IO processor 2, IO processor 3. All are competing for system bus and memory. So each IO processor controls and manage the input and output tasks. The IO processor is similar to general purpose processor except that it handles only the details of IO processing. The IO processor can fetch and execute its own instruction. It is most important thing. So the IO processor can fetch and execute its own IO instruction. So that is the specialty. If this is my IO processor, it can fetch, decode, execute and store only IO instructions. Just like normal processor, it can do fetch, decode, execute and store. But both IO processor and general processor are competing for, remember, there is only one system bus and memory. These IO instructions are designed to manage IO transfer only. Now, let's see the block diagram of a IO processor. The block diagram of a IO processor, we'll see the block diagram of a computer along with various IO processor. The memory unit, let's see, the memory unit occupies the central position and can communicate with each processor. So what's happening here? If this is my processor and these are IO processors, all are competing for memory. So the memory unit occupies the central position and can communicate with each processor. Next, the CPU processes the data required for solving computational tasks. The CPU in general processes the data required for computational tasks. Uh, the IO processor provides a path for transfer of data between peripherals and memory. The CPU assigns the task of initiating IO program. The IO processor operates independent from CPU and transfer of data between peripherals and memory. So here IO processor is completely independent, is completely free from CPU, and it can transfer the data between peripherals and memory without involvement of the general processor. Let's look at the block diagram of an IO processor. See here, this is the memory unit and this is an IO processor. This is an IO processor. So this is my main memory unit and this is IO processor, and here is the general purpose processor. And Remember, see here, these are peripheral devices. These are peripheral devices, and these are the device controller, peripheral device controller, which are connected to IO processor, not processor. But here the problem is both processor and IO processor, they have to compete for memory bus, or you can call as system bus. There is only one system bus, both processor and IO processor has to compete to use it. So this is called block diagram of a IO processor. So I'll repeat once again. Here what's happening, IO processor is connected to peripheral devices. So it can transfer the data independently from these peripherals via IO processor using memory bus to memory unit. Or similarly, data can be transferred from memory unit to IO processor to any peripheral device controller. So this is how it works. So without involvement of the processor. So the data can be independently, if this is my data, this data can be transferred to memory or from memory to peripheral devices without involvement of processor. Only IO processor can do this job. So these things you should try to understand. And IO processor can do fetch, decode, execute and store operations. These are the instruction execution cycle. So let's try to understand. The communication between the IO processor and the devices is similar to the program control method of data transfer. It is most important. So the IO processor and peripheral device similar. When the peripheral device is ready, when the device is ready, it sends signals to device controller. This device controller and the IO processor continuously monitor it. Program controlled method means you have to write a program. Remember, we have seen program controlled data transfer. The IO processor will be in the wait state. It continuously monitors the device controllers. So the IO processor continuously monitors. It continuously checks the status of the IO devices. So there is no other job for the IO processor. So and extra hardware is not required like for interrupt. So the best method of IO data transfer technique that IO processor can utilize is programmed IO data transfer. So what happens in case of programmed IO data transfer? The IO processor continuously monitors. It continuously monitors the status of each device, and so by this way this is in wait state. As and when the data is ready, it can initiate. If it is a large data transfer, then it has the capability of doing DMA. So whenever see the general processor, the communication between general processor and IO devices are not through programmed data transfer. We said when we discuss about programmed data transfer, we said that there is a disadvantage, like processor has to be in the wait state, unnecessarily busy in monitoring the status of the device controllers. But the same thing is advantage for IO processor. So it uses programmed, the IO processor uses the technique called programmed IO data transfer. And the importance of this programmed IO data transfer technique is that no extra hardware is required. No extra hardware is required for programmed IO data transfer. But the only thing is that the IO processor has to continuously check check or monitor the status of the device controllers. So the communication between IO processor and the devices is similar to the program control method of data transfer, and communication with memory is similar to direct memory access. So here one more thing. In case of communication between the IO processor and memory, this communication is like DMA. This communication is like programmed IO data transfer. These things you should understand clearly. So the communication between IO processor and the memory unit is much like a direct memory access. And the communication between the IO processor and the peripheral devices can be done using a technique called programmed IO data transfer. So before understanding these two concepts, you should have some idea what is meant by DMA and what is meant by programmed IO data transfer. Just now I said DMA is used to transfer large amount of data. If I have large amount of data, then I can use DMA is used. In programmed IO data transfer technique, what happens? As I said, the IO processor has to continuously monitor the status of each device controller. If it is ready, then it initiates the transfer by using a technique called DMA. So this is how IO processor works. And in large scale computers, each processor is independent of other processors and any processor can initiate operation. Large scale computers, in the sense they have more than one IO processor. Here IO processor 1, IO processor 2, IO processor 3, like this. The CPU can act as a master and the IO processor acts as a slave. This is most important. The IO processor acts as a in case of multiple IO processors. If I have more than one IO processor, in this case, this is called CPU is called master, and these are called slaves. In what aspect these are slaves? In the sense, in the aspect of sharing memory and system bus. So if any of IO processor wants memory or memory bus or their system bus memory, then it should make a request to the master. The CPU controls the sharing of memory bus and memory unit. That is what mean by master. The CPU can act as a master and IO processor act as a slave processor. The CPU assigns the task of initiating IO operations, but it is the IOP which executes the instructions and not the CPU. If processor finds an IO instruction, it handovers that instruction to any of the IO processor. The CPU instructions provide operations to start an IO transfer. Then IO processor asks for CPU through interrupt. So the IO processor generates and uses the concept called interrupt to communicate with processor. So the processor, as I said earlier, if I have more than one IO processor, they generates interrupt request to CPU. They generates interrupt request to CPU. So they make use the concept called. So the communication between IO processor and CPU is through concept called interrupt. The communication between memory and IO processor is like DMA. Communication between input devices is programmed IO data transfer technique. This is very important to understand. The communication between IO processor and CPU is using through interrupt. The communication between IO processor and memory is like through DMA, and the communication between the IO processor and peripheral devices is using programmed IO data. This is most important thing to understand. Next, instructions that are read from memory by an IOP are also called commands to distinguish them from instructions that are read by CPU. So when IO processor reads the instructions from the memory, they are called commands. But of course, these commands has to fetch, decode, execute, and store. It is common, but they are called commands from IO processor point of view. Commands are prepared by the programmers and are stored in the memory. Commands words makes the program for IO processor. CPU informs IOP where to find commands in the memory. So once the CPU finds an IO instruction, it handovers to IO processor. This IO processor communicates with memory to fetch those commands and execute. Next, we see an important concept called system bus in computer architecture. The system bus, as we have seen earlier, is the most important from system bus is the one which communicates the memory and to processor to an DMA and also to an IO processor. So all these things has to be, if processor wants to communicate with memory, it has to use system bus. If the DMA wants to communicate with memory, it has to use system bus. Similarly, if IO processor wants to communicate with memory, it has to use system bus. So system bus is the very important, and it's very important to know what system bus contains. So this, when CPU sends various data lines, when CPU sends various data line values and instructions and information to all the devices and components inside the computer. In general, what happens, the CPU sends various data values or instructions or information to all the devices. All the devices means memory or IO interface and components inside the computer. If you look at the bottom of the motherboard, you will see a whole network of lines or electronic pathways that join the different components. When you look at, if you get a chance to see the motherboard of a digital computer or desktop computer, uh, if you try to open the CPU, central processing unit, there you can see the important part called motherboard, and this motherboard contains a network of lines or electronic pathways that join the different components together. This network of wires or electronic pathway is called bus. So this is called bus. So first thing is that you should understand that bus is a actually a electronic path or network of lines. These are called network of lines or electronic path. They reside in the motherboard. If this is my processor, IO devices, memory, IO interface, all this connected using this network of lines or electronic pathways, which is called bus. See here you can see a real picture of the bus. This electronic path is called system bus, which communicates with processor. Here is I have processor, and somewhere you can see the main memory slots, main memory slots can be somewhere else. So this is basically, yeah, these lines are called system bus. So a bus is a communication pathway connecting two or more devices. A key characteristic of a bus is that it is a shared transmission medium. That means whoever wants they can use this transmission medium. Just now we said that if processor wants to communicate with memory or IO devices or IO interfaces, it will use the bus. If the DMA wants to communicate with the IO interface and memory, it uses system bus. Similarly, if you have a IO processor, dedicated IO processor, which initiates data transfer by accessing memory and IO interfaces, then also it uses system bus. So it's basically a shared transmission medium. Multiple devices connect to the bus, and a signal transmitted by any one device is available for reception by all other devices attached to the bus. That means how bus works actually means, if this is my memory and this is processor, and this is called processor, this is my memory, this is called processor, this is called DMA. So anyone which can transfer, anyone which connected to, if this is my memory, this is my processor or DMA or IO processor, if the data is over here, anyone can access. So multiple devices connect to the bus, and a signal transmitted by any one device is available for reception all other all other devices attached to the bus. If two devices transmit during the same time period, their signals will overlap and become garbled. Thus, any one device at a time can successfully transmit. So, before only one device has to use this system bus. It is the most important thing. All the devices cannot send the signal at the same time. What happens with this? The signals will collide each other. So only one device can grab the system bus and send the signals. Why we are speaking about signal means these electronic devices communicates by sending signals only. This is most important. Typically, a bus consists of multiple communication pathways or lines. Each line is capable of transmitting a signal representing a binary 1 or 0. So just now we have seen in the motherboard, like that means here I have 4 lines, so 4 bits data. Each wire can send 1 bit of information. Each wire can capable of sending 1 bit of information. Typically, a bus consists of multiple communication pathways or lines. Each line is capable of transmitting signal representing binary 1 and 0. Several lines of a bus can be used to transmit binary digits simultaneously. For example, 8-bit unit of data can be transmitted over 8 bus lines. Computer systems contain number of different buses that prove pathways between components at various levels of computer system hierarchy. Now we see system bus, a bus that connects the major computer components like processor, memory and IO is called system bus. So a bus which connects the major components, processor, memory and IO. These are the three major components. So these are called system bus. A system bus consists of A system bus consists of typically of from about 50 to hundreds of separate lines. Each line is assigned a particular meaning or function. System bus contains about 50 to 100 lines, so they can carry 50 to 100 bits. So a system bus is usually separated into three functional groups. One is data bus, another one is address bus and control bus. In addition, there may be power distribution lines that supply power to attached modules. There are also some lines which sends power to these components, to the major components like processor, memory and IO interface. But whenever you say system bus, it has three components. It is separated into, it is grouped into three functional groups. One is address bus, data bus, control bus. So if these are all are line only, so this is called, let's assume address bus, this is called address bus, this is called data bus, this is called control bus. All together we call it as a system bus, but they are grouped according to the function what they do. So this is a system bus module. In system bus module, what's happening? CPU, registers and control, the memory and IO interfaces, all are communicating with utilizing the data bus, address bus and control bus.